So today our class is Computer Organization, Module 4, Lecture 7. Now, you know that you can recall that for transferring the data from the particular I/O device to memory, there are three techniques. One is called the programmed I/O, another is called the interrupt-driven I/O, and last one that today we will learn is the direct memory access. What happens in the programmed I/O? In the programmed I/O, that is a program, and using that program, I will check the status of the I/O devices, whether the device is ready to transfer or not. Okay, and when the I/O device is ready, the data can be transferred from the I/O device to the memory with the help of the CPU. Okay, here one thing is important, that no interrupt signal is used in case of the programmed I/O, that we have already learned. Okay, and then next comes the interrupt driven I/O. In case of the programmed I/O, what is the disadvantage? Disadvantage is that after some periodic time period, after some period, CPU has to take whether the device is ready to transfer the data or not. Clear? But in case of the interrupt driven I/O, CPU every time don't have to engage. Whenever I/O is ready or I/O required to transfer the data from memory, or I/O has to read the data from the memory, it will send one interrupt signal. Then CPU will stop its current work. It will go to the some interrupt handler and interrupt service routine or interrupt handler. Then it will service the particular I/O device. In the interrupt service routine, the software for the particular I/O device is written. Okay, so this is the interrupt driven I/O, where interrupt signal is used to transfer the data from I/O device to memory or from memory to I/O device. Clear? But see here, in both the cases, CPU is involved. Here it is written I/O to memory transfer through processor. That means both in the programmed I/O and interrupt driven I/O, CPU is involved with the operation. Okay, but today we learn a different technique where the data can be transferred from the memory to I/O device without the intervention of the CPU. That means CPU don't require to transfer the data from I/O to memory. There is a separate device that is called the direct memory access or direct memory access controller. With the help of that, memory data can be transferred from the memory to the I/O or I/O to the memory. That means in that case, DMA will be the master of the bus. In the previous cases, that means the programmed I/O and interrupt driven I/O, CPU is the master of the bus, and processor and I/O has to intervene. The I/O have to take the help of the CPU for transferring the data. But in this case, direct I/O to memory transfer, that means DMA transfer, there is no requirement of the CPU. CPU can do the some another function when data can be transferred from the I/O device to memory and memory to I/O device. In the previous cases, CPU cannot do another task when I/O device is working. But here CPU can do another task, and in the meantime, data can be transferred from the I/O to memory or memory to I/O with the help of the direct memory access. That means in that case, DMA will be the master of the bus. Okay. So see here how DMA operates. Okay. So what is the advantage of the DMA? Advantage of the DMA is that DMA increases the speed of the I/O service by eliminating the role of the CPU. That means there is no requirement of the CPU to transfer the data from I/O device to memory or memory to I/O device. That means in the meantime, CPU can do some another operation. So the performance of the system will be increased because CPU will not wait for the I/O device, which is actually the slower device compared to the CPU. Okay, if you CPU do the I/O operations, CPU has to wait because you know that I/O device is directly connected with the human, and human is very slow. So obviously I/O device will be slow compared to the CPU. So if you CPU take the responsibility to control the I/O, the performance of the CPU will be decreased. But in case of the DMA, there is no requirement of the CPU. DMA will transfer the data from I/O to memory and memory to I/O. So obviously the performance of the CPU and the whole system will be increased. Okay. Now there is a DMA request line. Why DMA request line? DMA request line is required because Actually, data is transferred from the memory to the register with the help of the CPU, and CPU is the master of the bus. So when IO wants to transfer the data from IO device to memory, IO has to request the CPU that please leave the bus. I will use the bus for transferring the data from the memory to IO or IO to memory. So there is a signal on DMA request line cause the CPU to suspend its current activities at appropriate breakpoint. What is breakpoint? I will tell later. Okay. That means it will ask the CPU that please stop your current work. That means, and please leave the bus for me so that I can use the bus for transferring the data from IO to memory or memory to IO. So that is called the DMA request. This request comes from the DMA controller, direct memory access controller. Clear? Now, in this case, CPU is not required to check the status. In the programmed IO, you know that CPU, after some time, CPU has to check the status. That means there is a period, and after that period, CPU has to check whether the IO device is ready to transfer the data or not. So every time, CPU has to check the status of the IO, and that is time consuming. So obviously the performance of the CPU will be down if the programmed IO is used. Clear? So then comes the interrupt driven IO. Here also, what CPU has to do? Here CPU don't have to check the status of the IO, but if interrupt occurs, CPU has to suspend its current operation and it has to go for executing another software or another program that is called service routine. That service routine is for the particular IO device. So here also CPU has to do the operation for the IO device. But in the DMA, I have already told there is no requirement of the CPU. If CPU leave the bus, it is the responsibility of the direct memory access or DMA to transfer the data from the memory to IO devices and from IO devices to memory. Okay. So a DMA request by an IO device only requires the CPU to grant control of the system bus. That means when there is a requirement of transferring the data from IO device to memory, there is a requirement of bus because the bus is common for the Dma architecture. So it will request the CPU that please leave the bus for me. That means please grant the bus for me so that I can transfer the data. Clear? So a DMA request by an IO device only requires the CPU to grant control of the system bus to the requesting device. Clear? So I have already told that CPU will grant the bus at the appropriate breakpoint. Now what is the breakpoint? In the previous case, in the interrupt, when interrupt comes, suppose CPU is doing some instruction, suppose executing some instruction, CPU can only service the interrupt routine only after the completion of the particular instruction. See, so for this it is written, this is the interrupt breakpoint. See, this is the total instruction cycle. You know the total instruction cycle. There is a fetch, decode, memory read, execution, and memory write. Now suppose interrupt comes here when CPU is decoding the instruction. CPU, in case of the interrupt service IO, CPU will not stop the decode instruction. It will also not stop the fetch, execute, and store instruction. It can only do the interrupt service routine after the memory write operation. That means that after the completion of this total instruction cycle, then it will do the interrupt service routine. How to do? I have already told that current address will be stored into the program counter, interrupt service routine. It will go there. It will execute the data into the execute the particular IO device using the interrupt service routine. Then it will again back to the particular instruction that they are currently executing. So the CPU can only execute the interrupt after the completion of the particular instruction. So here this is the breakpoint of the interrupt. But see, these are the DMA breakpoints. That means suppose CPU is fetching some instruction, a request from DMA comes. Okay, suppose CPU is fetching the instruction, it is here in this point, and some request from DMA comes that please leave the bus so then I can transfer the data. CPU can leave the bus at this point if it is executing here, 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 and at this point it is the executing GR. That means this is the breakpoint of the CPU in case of the DMA. But for the interrupt, this is only the breakpoint. That means only after the memory write operation. So DMA, what are the DMA breakpoints? This one, this one, this one, this one, this one. Here there are 5 DMA breakpoints, and there is only one interrupt breakpoint. So when DMA request comes, CPU can grant the bus at this point, or this point, or this point, or this point, or this point. But when interrupt comes, CPU can only do the interrupt service routine at this point, not this, 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 and this. So this is called the breakpoints and DMA breakpoints. Clear? Now this is the transfer mode of the DMA. I have already told that DMA can transfer the data without the intervention of the CPU. But CPU will, suppose CPU is doing some work, that means that is CPU is using the address, data, and control bus of a system. Clear? Then what are the transfer mode? There are the 3 types of transfer mode for transferring the data from the IO device to memory and from memory to IO device. First one is called the burst mode. That is called the DMA block transfer. What is the meaning of that? Meaning of that is that data word sequence of arbitrary length is transferred in the single burst, while DMA is the master of the bus. CPU cannot acquire the bus at that time. That meaning is, suppose there are single block, there are 8 words. If CPU is working or DMA is working in the burst mode, CPU cannot take the bus from the DMA until the completion of the whole block. That means, suppose there are 16 words in a block, only after the completion of the 16 words, CPU can take the bus from the DMA. In the mid position, it cannot take the bus. That means, suppose after transferring 3 words, it cannot take the bus from the DMA. It has to wait after the, so that the total 8 word is transferred from the IO device to memory or memory to IO device. So that is called a block transfer mode or burst mode. The meaning is the total block, after transferring of the total block, then CPU only can regain the bus for transferring the data from register to memory. That is called the block transfer mode or burst mode. Okay. Second one is called the cycle stealing mode. What happens in the cycle stealing mode? Here DMA transfer one word and return the control to the CPU. That means DMA is a slower process, you know, because it is related to the IO. CPU is a fast process. Suppose CPU is transferring the data, DMA sends the request, CPU grants the bus to the DMA. Instead of the total block, it will first transfer the one word, then it will again give the bus to the CPU. CPU will do some operation, then again it will grant the bus to the DMA. Then DMA again transfer the second word. In this way, word by word, it will transfer, DMA will transfer the data from the IO to memory or memory to IO. That is called a cycle stealing method. And all the cycle stealing methods will be happen in the appropriate breakpoint. Suppose one breakpoint, DMA transfer one word. Then in the next breakpoint, then it will grant the data, grant the bus to the CPU. It will leave the bus to the CPU. CPU will do some work. Then comes the second breakpoint. Again, in the second breakpoint, DMA will transfer the another word. In this way, cycle stealing method works, and DMA transfer the data from memory to IO to memory. This is the second technique for transferring the data using the direct memory access. Last one is the transparent DMA. This is another technique, and in this technique, what happens? When CPU is not actually using the bus, CPU is doing some another work, then only DMA can use the bus. This is called the transparent DMA mode. That means in this case, what happens? Suppose DMA is requesting the bus. CPU will not leave the bus because it is using the bus. After the completion of the bus operation by the CPU, suppose CPU is executing some operation in the register, it don't require any bus, then only DMA can take the bus. This is called the bus cycle stolen method. Okay. That means when CPU is sitting idle or doing some another work, it is not using the system bus, then only DMA can get the bus or CPU can grant the access of the bus to the DMA. So this is called the transparent DMA access mode. Good. So next one is the DMA architecture. If you see the DMA architecture, it will be clear. See here, this is the main memory. We know that data will be transferred from the CPU register to the main memory using the three buses. You know that three buses is data, address, and control. Function of the data bus is to transfer the data from memory to register or memory to IO device, and register to memory or IO device to memory. Address bus, you know, to access the particular address memory location or the IO location. Clear? Because IO device has some address and memory location, you know, some address. So this is the function of the address. And control bus, you know, that to generate the different control signals so that the data can be transferred from the one device to another device. You know how the control signal works. Clear? So these are the three buses. Now when CPU will transfer the data from the register to memory or memory to register using the data bus, suppose at some time there is a requirement of IO operation. So CPU will put the particular address of the IO, that means which IO is required to transfer the data, IO address, particular address of the memory, and the data counter, that means what is the total data required to transfer from the IO device to memory. Okay, so it will first put these two information here. This is called the DMA controller, which has the data counter, which contains the total number of data to be transferred. IO register, this is the address from where data should be transferred. Okay, and this is the data register, that means that from IO device data will be temporarily stored here, and from this data will be go in the main memory. Similarly, from the main memory data will be first transferred to the IO data register, and from this register it will go to the particular IO device. So total is the DMA controller, and that is the control unit. This control unit actually controls this total DMA operation. Clear? So when there is a requirement of data transfer, CPU first put these two information here. What is the total number of data required to transfer, and what is the address? So control signal will give the DMA request. That means it will request the CPU that please grant me the bus. That means please leave the bus. So I can use this bus to transfer the data from this device IO register to the memory, because CPU is actually use this bus for transferring the data from this memory to the register file. So suppose CPU is doing some work, depending on the different types of transfer mode, that means the burst mode, CPU stealing mode. Okay, it will leave the or grant the bus. Okay, it will grant the bus and it will send one DMA acknowledgement signal to this DMA controller. That means it will tell that, see, I have leave the bus and I have granted the bus to you. You can use the bus now. So when this controller gets the DMA acknowledgement signal, it knows that bus is not now will be used by the CPU. So it will transfer the data from main memory to IO device. It will transfer the data, and this counter will be decreased. That means suppose we have to transfer 50 words. Then after transferring one word, it will be 49. After transferring another word, it will be 48. That means this is the data count. This count will be decreased, and when the total transfer operation is completed, DMA controller will send one interrupt signal to the control unit or CPU that it will tell, see, I have completed my operation. Now you can use the bus. Okay. So CPU now, if required, they use the bus. CPU will use the bus for transferring the data from main memory to register or register to main memory. Yeah. This sequence of operation is written here point by point. See here, first CPU loads the IO address register and data counter with the initial values. So data counter and IO address register with the initial values. Clear? That is the initial address from where data has to be transferred. Now, when DMA controller ready, that means when the IO device is ready to transfer, IO device is not engaged to another operation, it will activate the DMA request line. That means it will request the CPU. This will activate the DMA request line. That means it will request the CPU that please grant the bus for me or please leave the bus. This is called DMA request. So after that, CPU waits for the next breakpoint. I have already told what is the breakpoint. When the appropriate breakpoint comes, it activates the DMA acknowledgement line. That means it will tell the DMA at the appropriate breakpoint. Then now, see, now I have granted the bus for you. You can use the bus for transferring the data. So that is called the DMA acknowledgement. That signal will go through the DMA acknowledgement line. So here, this is the DMA acknowledgement line. When this acknowledgement signal is received by the DMA controller, it knows that now it can use the bus. Clear? So here, DMA transfer directly to or from memory. IOAR and data counter are updated. IOAR because suppose one data particular address is transferred, then address is again changed, then address is again changed because data is transferred to some particular address. So IOAR, this register will be updated and data counter will be decreased because suppose it requires to transfer 15 words. So 1 word, 2 word, 3 word. So it will be transferred and data counter will be decreased 15, then 14, then up to it will go when the data counter is 0. Clear? So it will data counter will be updated and DMA transfer the data directly from memory to IO device or IO device to memory. There is no requirement of CPU here. So if data counter is 0, that means all the data you have transferred, but if data counter is not 0, that means all the data is not transferred yet, but IO no longer send the data. That means there is no requirement of data. Okay, or there is some problem in the IO device and IO cannot send the data. Both can happen. In this case, DMA deactivates the DMA request. It will deactivate the DMA request line and it will tell the CPU that I don't require the address line or data line further, you can use it. Okay. Processor deactivates the acknowledgement line in the same time if it gives the DMA, deactivates DMA request. Okay. So now processor can use the data for transferring the bus for transferring the data from the memory to register or register to memory. Okay. Suppose DMA DC is 0, that means data counter is 0, that means all the data has been already transferred. DMA may release the bus by sending an interrupt signal. Here also in these two cases, when DC is not 0 but IO no longer sending the data bus will be given back to the CPU, and when data counter is 0, DMA release the bus and will tell it will send one interrupt signal to the CPU and tell that, see, I have completed the transfer operation, you can use the bus now. So in this case, CPU will again use the bus. Clear? So this is the direct memory access. So we learned about the 3 types of IO operation. Programmed IO, where status have to be checked every time CPU that whether it is ready or not for transferring the data. Then comes the interrupt driven IO, where processor don't have to check the IO device every time, but what will happen? But it has to service the interrupt. That means the service routine, it has to execute the service routine written for the particular IO device for transferring the data from IO to memory or memory to IO. And this is the totally, in both cases, CPU is involved. But this is the third case. Here you have seen that here with the help of the DMA, data can be transferred directly from the IO to memory or memory to IO. Okay. And there is only with the help of the DMA controller. There is no requirement of the CPU for only transferring the data, because transferring the data is a slow process because it involves with the IO device, and you know that IO device is always a slower device compared to the CPU or the memory. Clear? So this is the function of the DMA. So this is for today, and thank you.